Good evening to all the distinguished participants, respected faculty members, and invited guests. I am Dr. Ayani Nandi on behalf of Ramgarh Engineering College. Truly delighted to welcome you all to day 3 of our faculty development program on alternative fuels and hydrogen energy, clean energy innovations for a sustainable society. After an enriching and insightful second day, we are excited to continue our journey of learning, exploring, and knowledge sharing. Today's session promises to bring even deeper perspectives, practical understanding, and expert driven discussion that will further strengthen our grip on the emerging trends and innovations in the domain. Your active participation, curiosity, and engagement have made day 2 truly successful. And we look forward to the same enthusiasm throughout today's schedule as well. Let us begin day 3 with new energy, open minds, and a shared commitment to advancing our academic and professional excellence. Wishing everyone a productive and inspiring day 3 for the FDP. On behalf of Ramgarh Engineering College, I take great pride in extending a warm and heartfelt welcome to our respected guest, Dr. Priyatam Kumar Sir, Professor in the Department of Electronics and Communication Engineering at KLE Technological University, Hubli. Dr. Priyatam Kumar Sir is a highly accomplished academician and researcher with over 25 years of rich experience in the fields of artificial intelligence, Internet of Things, embedded systems, and sustainable energy technologies. Over the years, he has contributed immensely to advancing smart and energy efficient systems through the integration of intelligent computing and IoT based automation. Dr. Priyatam Kumar Sir expertise as a professor with 25 years of experience likely focuses on how to use AI and the IoT to create more efficient and sustainable energy system. This includes smart energy management for microgrids, residential settings, and large-scale smart cities, optimize renewable energy integration, and improve overall energy efficiency. His extensive research and teaching experience have helped bridge the gap between the emerging technologies and sustainable engineering practices, inspiring students, researchers, and professionals. Dr. Kumar's expertise lies in developing intelligent framework and IoT-based solutions that optimize energy use, promote renewable integrations. The application of his research and innovations are smart cities, implementing systems like smart green energy system for fine-grained control of energy use across various urban sectors. Note this E3S Web of Science conference. Another innovation is creating microgrids, creating advanced energy management system for microgrids that can use AI to predict weather impact, optimize battery storage, and improve financial saving. And also residential and industrial settings, developing system for accurate energy monitoring and load management to promote conservation and efficiency. The aim of such work is to achieve significant energy saving, battery integration of renewable energy sources, reduced waste, and contributed to broader environment goals like those in the United States Sustainable Development Goals as highlighted by ResearchGate. On behalf of Ramgarh Engineering College, I, Dr. Ayani Nandi, once again extend a warm welcome to you, sir, and express our sincere gratitude for gracing the FDP with your expertise and presence. I also take this opportunity to welcome all the participants, faculty members, and dignitaries who are part of this important academic initiative aimed at promoting innovation, sustainability, and technological advancement. May I now request you, sir, kindly share your thoughts and inspire us with your words. Sir, you can start now.
Yeah, thank you very much, madam, for the introduction.
Thank you, sir.
Am I audible, madam?
Yes, sir. Yes, sir.
Yeah. Okay. Thank you. Today, I'm talking on the IoT for sustainable energy management. So, as we are talking about the energy management, whenever we are talking on the energy, we will have the hydraulic energy, we will have the solar energy, we will have the wind energy, and we will have the battery energy where the stored energy can be used for the system. Now, the interesting part of the system is whenever I am using this energy, to what extent or to what level I am trying to use the energy. So, if you look at one simple example of the home applications. So whenever I'm talking about the home application, we have the lighting system, we have the refrigeration system, we have the microwave system, we have the other appliances like air conditioner and other appliances which we are trying to use in the system. So here the question is, are we using all these equipments in the proper manner? Most of the time the answer is no. Because if I'm using a room, in that I would like to have the fan, I would like to have the AC, or I would like to have the proper lighting system in the room. If I leave the room, what will happen? Have I switched off everything and go out? Or I will keep the things as it is and move out. So here the second part is, if I leave the things as it is and I'm moving out, it means that we are not utilizing the energy in the proper direction. So hence we are losing the energy. That means when I'm not using it, I should have switched off or I should have made the alternative arrangements, but which I am not doing. So I am wasting the energy. So whenever I'm saying the wasting of energy means we are leaving the carbon footprints. That means if I'm using something for a particular application, for a particular usage, it is appreciable. If I'm not using, but I'm using the resources, that means I'm losing the energy. So here our interest is how to manage these things. Somebody has to manage these things. So now most normally what happens at the residential places is mother or the elderly people will take care. If somebody is not there in the room, he will switch off the fan, the light, everything. But somebody has to take care of this. So that's the reason why we are going for Internet of Things. So here we are trying to make use of some smart system through which we are trying to control all these things, and in turn we are saving the energy. It very clearly says that if you save 1 unit of energy, it is equivalent to production of 2 units of energy. If energy is utilized properly, then the quality of life is much better. So now there is a saying that whatever the energy, hydraulic energy I'm talking about, is produced in the grid level, the transmission process, it is going to lose at about 20 to 23% of energy in the resistance. Just Ohm's law, V is equal to I into R. So we are losing, but it is getting converted into heat and we are losing in the transmission process. So there are several techniques has come up. So from the grid, there is an effort is going on to have the wireless process. That means the energy has to get transmitted by means of wireless system. A lot of research is going on that. And once it is through, that means the transmission, the losses can be minimized. So that's one part. Second part is most of the energy is used by the consumers. Whenever you are using the energy, how you need to control this energy such that there should not be any loss, or it has to be optimally used or effectively and efficiently used in the practice. So there is two part. One is artificial intelligence, and the second part is IoT. So whenever I'm talking on the IoT, it got a setup where it it looks the overall performance of the system, getting the energy, converting it, using it through the cloud or somewhere else. You are getting the data and working it out. So whenever I'm talking with the cloud or something like that, I need to effectively identify where my data is located. And I have to fetch that data and use that one. So for that particular purpose, we are trying to make use of the artificial intelligence. So the artificial intelligence will provide us the algorithms, and IoT will give us the hardware solution. When we club these two, it becomes the firmware, and through which we are trying to get some effective means such that we are able to save the energy and which can be utilized for some other purpose, and which will reduce the uh, carbon footprints, which we are having a lot of losses can be minimized. So today in my talk is how the IoT is going to be used and what are its constraints, advantages, disadvantages, and what are its components, and how making use of the IoT, we are able to get a proper utilization of the energy and how we are managing this energy. So let us start with the fundamental thing. So here, if I look at the I'm not able to move this to the next slide. Yeah. Okay. Now, if you look at into the AI and IoT. So as I told, the artificial intelligence and Internet of Things technologies, which are got an potential way to manage this energy systems. That is one part. Second part is the sustainable energy management. Sustainable energy management will talks about the goals and importance of sustainable energy management. Whatever the means of energy we are trying to produce, hydraulic, solar, wind, or any stored energy, how we are able to make it sustainable for the application purpose. So that's the main goal of our system. So now, what is this? Why we need the energy management system? The basic question. So whenever I said, whenever we are using any energy, it has to be used optimally. We have to use optimally. And whenever I'm trying to use it optimally, how best I can convert from one process to the other. So the AI and IoT based energy management system collects the data on energy consumption and the applies to the real analytics. So it says that for any application, say for example, if I'm using for household purpose, normally we say that it is 3 kVA. That is the amount of energy, maximum energy what we can utilize from the grid. So when I'm getting 3 kVA, how optimally I can use the system? It's very clear that can I put the entire load simultaneously onto the system? That means I have to switch on my air conditioner, switch on my motors, switch on my lighting system, switch on my fans, everything. The load. That is one option. Second option is, can I use only the things which are essential for that moment, which are essential for only for that moment? If I want to try to use only such kind of things, then I need to collect the data. So the data collection is that when I'm going to use maximum power and when I'm not going to use maximum power. Say, for example, in the daytime, if I got a proper ventilation system, I may not use the lighting or I may not use the fans. So I have to discriminate the things like when I'm going to use these equipments and when I'm not going to use these equipments. So that is the data. So over the period of 24 hours, if I'm able to get this kind of data, when and what kind of energy I'm consuming in my real life. So that is what I need to look into. And then these resources, whatever I am trying to use, I have to use some strategy such that a uniform distribution of a load onto the grid has to happen. Otherwise, what will happen if I'm trying to use more than the desired value? There is a possibility that the system will get into the cutoff. If nowadays we got the cutoff systems. Once if you go beyond certain limit of your capacity, then automatically it will get tripped. So when it is get tripped, I am uncomfortable because I am trying to use it, but it is getting tripped. I am uncomfortable. So here I have to minimize that uncomfortableness in the system. So that is where I need to look for some strategies. Through the strategies, how I am able to work out the things. So it is very clear. Now I have to have a, a database. So in the database, from 0 to 30 days, so 1 month period. And in that, I have the classification of daily consumption. And in the daily consumption, further, I am reducing it into hourly consumption. So in the hourly consumption, what is happening over one day from midnight 12 o'clock to the next day midnight 12 o'clock, when and what all the kind of energy, to what level I'm using the energy in the system. So I have to make the chart prepared for that particular thing. So once if I'm able to get that Gantt chart, then I have to work it out for the month. So that is where the utilization in the real time, the energy utilization in the real time I'm able to get, and then how to manage these things, how to manage with these things. So that is where the strategies has to come into the picture. Okay. Then now we will see the process of IoT, which can go for the time energy monitoring. So in the time energy monitoring, we have the first part is IoT sensors. So this is IoT sensors are able to collect the real-time data on energy usage from various equipments and the systems. Sensors are those, we will call them as the converters from one form into the other form. So here we are converting the energy into the voltage. So this voltage is going to be used for defining the various conditions. So sensors are the transducers, which are going to convert from energy from one form to the other form. So here we are converting energy into the voltage level. That voltage level is further used for processing the things. And second one is the smart meters. So these smart meters, see, look at the earlier meters, the difference between earlier meters and the smart meters. Earlier meters, what used to happen, whatever you are using, it is keeps on showing you the readings. So what we can see is how much energy we have consumed per hour or per day or per month, that we are able to see it with respect to the general earlier meters. And now here we are going to have the smart meters. So the smart meters will try to give you the feedback. So it is not a open loop system, it is a closed loop system. So in the closed loop system, it provides you the instant feedback on the consumption on your phone or on your any electronic device which you are connected through. So it tells that for this moment, your energy consumption is very, very high. So I can realize, okay, I have done switched on so many things. Now I have to switch off them. So by means of the feedback, I'm able to detect where exactly I'm trying to consume more power. Can I reduce that power or can I switch it off such that I can get into the allowable range? So these smart meters will give you the instant information regarding the consumption of your usage. And third one is the cloud computing. So cloud computing, earlier I told you, I want to see the things with respect to hour basis energy, day basis energy, or monthly basis energy, or yearly based energy. So when I'm working with all these things, the data is going to be produced. So where I have to store this data, because there are not an individual or a single data process is going to be exist. There are going to be the multiple system. Lakhs or crores of people are using the system. The data is going to be enormously large. So here we are trying to use the cloud. So cloud is able to use or store the energy, and from that cloud, whenever is required, I can fetch the data and I can process the things. Now, the thing is, I'm storing the data into the cloud. So in the cloud, the data is going to be very large. Say example is if I talk about the library. Now I want a particular book. If I get into the library, can I get easily that book? Answer is no, because it has to be located in a particular location, and I have to go to that location and get it, and I should know where that book is available. So what I am trying to do there, I am trying to use the computer and typing the book name, then it will give me the shelf number and other details. So straight away I can go there and pick that book. That means the access time which I'm trying to use to access the data in the library is becomes faster. In any system, the accessibility, or we'll call it as the bandwidth, it has to be faster. So the access time has to be very, very less. That means I'm able to process the data at the faster methodology. So when the data is very large, like in the library, when I'm looking or searching for a book, it becomes a tedious job. If I start with the book number one and keep on searching, it will take a lot of access time. How to reduce that access time? So here we are trying to make use of the artificial intelligence or machine learning process. So the artificial intelligence and machine learning process, it will predict, when you are going to use more energy, when you are going to use the less energy. So there are algorithms. Through the algorithm, it will try to predict when you are going to use and when you are not going to use, because you have the daily routine data is already available in the cloud. So based on that, it has to fetch or take the process and then optimize the consumption. So optimizing consumption means it will tell you, it will provide you the information saying that in this particular, say your geyser is on for a quite long time. Normally it is geyser has to be used for 10 minutes, but already it is 15 minutes. Still you are not switched it off. So that kind of data is optimizing. So it is intimating you that switch off your geyser. If you have forgotten sometime, you can go and switch off the thing. So the artificial intelligence or the machine learning will try to, through the algorithm, it will predict and then it will optimize. Then it will talk about the amount of energy consumption in the system, and it will detect the anomalies. Anomalies is when you are not using. Say in my room, AC is on, but nobody is there. It is a waste of energy. So it will detect such kind of things and intimate you by means of some logical or by means of some gadget, either onto the mobile or onto the system. So when you get a notification on your mobile or system, immediately you are trying to work on those things. So that is where the AI is going to be used. On the same lines, either you can use the AI or you can use the blockchain technology. So this blockchain technology will go for decentralization of the energy. So the decentralization of energy means normally we will have the electric consumption line is separate and AH line is separate. Likewise, so you are, whether you are using more energy on the lighting system or you are using more energy on the AH. So that is weight. The decentralization has to be happen. So that is taken care by the blockchain technology. So now what happened? I have sensed the data. I have meters where it will tell that what is the energy you are trying to either using more or less. Then it is going to be stored in the cloud. In the cloud, large data is there. By means of blockchain or AI, you are trying to fetch the desired data. How this fetching and other things will happen? So here we are using the wireless communication protocols. So here we are using Zigbee or LoRaWAN. These are the different facilities which we are trying to use in the system, which we are trying to use in the system such that I am able to communicate from the device onto the system. Nowadays, we are using very much Wi-Fi for the data transmission and other purpose, because no, earlier we have the wired connection, so it was only for a limited purpose. But because of the Wi-Fi, I got the larger bandwidth and I'm able to communicate with respect to any system anywhere. So that's how the 5G and 6G are used nowadays. So most of the people are using now fifth generation wireless communication process, through which we are able to make the data flow in a comfortable manner or in a quick and faster manner. And then we have the edge computing. So when I'm talking about the edge computing, it talks about the response time. Response time means whenever something went wrong, how much time is required for me to respond for that particular issue. I told earlier also, whenever something where the electrical equipment which is in use, but I'm not using it properly, I have to get some intimation. So that intimation is called the response time, or we'll call it as the latency. If something goes wrong, how quickly I am going to respond. If the latency is very less, it is called as the more efficient system. If latency or delay is more, then we'll call the system is not that quick response in the practice. So that is where the edge computing, that means how quickly I'm able to make the decision and pass the information to the end user such that he can use in the comfortable manner. And the next part is the big data analytics. So the big data analytics is I got very large amount of data. Is that entire data is useful to me? Answer is no, it cannot be useful. Only a part of the data. Nowadays, we have a lot of algorithms for that, whether it is the required data or not required data. And if it is required, is it essentially required or essentially not required? So I need to go for analysis of these things. So if you go to a supermarket, example I'm trying to quote here, if you go to a supermarket, lot of commodities are there. Are you going to buy all of them? Answer is no. That is the big data. Means there are several items are exhibited in the mall, but I am going to pick whichever is required for me. So when you go to the mall, you will not only pick the required one, you will get some useless things also. You feel that after some time or later on, I can make use of these things. How true it is, that is not known. So here also in the big data analytics, I have to make whatever, there are going to be several data. Out of this several data, I have to look for the essential data. And in the essential, the required data, that is called as the optimized efficiency. So optimized efficiency. So based on that, I have to narrow down the problem or the issue. Then I have to try to make use of these things. And now everything is fine. As a user, should I communicate everything? I have to say that now I switched on my uh, heater, I switched on my microwave, something like that. And then it is going to tell me, okay, the time is over, you have to switch it off or something like that. It is not possible thing. So as a human being, I will switch on. So the system has to take care of it. So that is where we go for the automated control system. So in the automated control system, now you can look at some two examples I prefer to give here. One is the iron box and second one is air conditioner. So whenever I'm using the iron box, what is happening? Once the switch on is done, continuously the heat will start increasing. And now if I allow it to increase just like that, what will happen? It go beyond certain level. When it goes beyond certain level, it is going to burn the cloth. That should not happen. So I am using the thermostat there. So in the thermostat, I have adjusted the temperature to 70 degrees, 80 degrees, whatever it is. So once the temperature reaches, automatically the system disconnect. And if it comes below certain value, automatically it gets the reconnected. Similarly with air conditioners, if you have set the air conditioner for 22 degrees, what will happen? The room temperature, if it reaches 22 degrees, automatically it goes off. And there will be a lower limit, like 20 degrees or something like that. Otherwise, what will happen? If I set it for 22, 22.1 is more and 21.9 is less. It keeps on switching there. So that will cause damage to the electronic system. Hence, what I do is, if I keep at 22, I have set the lower limit as 24 degrees or something like that. So once the temperature, room temperature reaches 22 degrees, the thermostat will automatically disconnect the power supply. So the room temperature will start increasing slowly, depends upon how many people are there in the room. Once it reaches somewhere around 24 degrees, then what will happen? The system will be switched on. So this is called as the automated control system. So here also, whenever I have switched on something, the system is continuously monitoring the parameters. So these parameters are controlled by means of artificial intelligence. So in the artificial intelligence algorithm, I have predefined for the air conditioner, the temperature has to be between 22 to 24. So based on that, automatically it will switch on and switch off. And if nobody is there in the room, it will look for a certain period of time, then automatically switches off the system. So this is where the automated control system is very helpful, and basically it is dynamically based, means online. If the system is on, this it is trying to take care of the things. Otherwise, it will pass it to the next process. Then the final one is renewable energy integration. It is not saying that all the time you have to use only the one power supply. There is a possibility that, say, nowadays we are using solar panels too. So if I'm using a solar panel during the daytime, I know I don't need the grid energy because straight away I can make use of the solar energy. So during that time, the grid energy has to be switched off. Or if I got an wind energy system, so it has to use the wind energy and it has to disconnect the grid and solar. So here, whichever system is developing more energy, I have to make use of that. And that is where the renewable energy integration means connecting several things. Whoever provides you the better supply, connect it and disconnect the remaining two. That has to be taken care in the system. And now, if I get into the parts of IoT. So IoT is the basic Internet of Things. So here I got the user interface, I got the cloud, I got the things, I got the analytics, and I have the gateway. That means what all the things get connected to the IoT. User interface is your system, and things or devices are the devices which are connected to the system. Cloud, where the data is available, and analytics, where through the AI and machine learning, I'm analyzing the things. And gateway is how I exactly I'm trying to control the system. So this is the basic schematic or the basic logical structure of the IoT system. If you look at the main parts of the IoT. So the first one is sensors and the actuators. Sensors is incoming. That means incoming signal to the IoT, and actuator is the outgoing signal, how I am trying to control the system. So I'm sensing the, say for example, talk about the temperature. So I'm sensing the temperature in the sensor. If that sensor is converting this temperature into the voltage and it is sent to the IoT. In the IoT, I am comparing with the standard values. What should be the room temperature? If it is in the tolerable range, there is no issues. If it goes beyond that tolerable range, then the IoT has to control through the actuator. So what the actuator does is it will switch on the air conditioner or it will switch on the fan. So the actuator is a mechanical system which changes, the physical change is going to be happen in the system. So in the sensor, I'm from the different means of analog signal, I'm converting either it into the electrical or electronic signal, and then I'm providing it to the IoT. And in the IoT, continuously it is monitoring. If it is within that tolerable range, there is no issues. Or if it goes beyond that the tolerate range, the actuator has to be initiated. So actuator, through the electrical signal, I am activating. That means through the relay switch, I am trying to provide the power supply to the air conditioner or whatever the system. So it is going to switch on the system. So sensor and actuator are input and output of the system. So I'm sensing the input and I'm acting accordingly. Take yourself as an example. So you are in the room. If the room temperature is nominal, you are comfortable, there is no issue. If it goes little high, you will start sweating or you are uncomfortable. What you will do? You will get up, go and switch on the fan. So sensing the things of the temperature is the sensor. moving out and switching on the fan is the actuator. So that's going to be the mechanical system. And second part is the controller. So controller is one which controls the system. On and off is a control process. So sensing the data continuously, and you are storing it in the cloud, and based upon the condition, it is going to initiate the actuator. So what is happening here? From the physical analog signal, I'm giving it to the sensor. From the sensor, I'm connecting it to the analog to digital converter, analog to digital converter. So once the digital information is there, that is going to be stored into the system, and it will start working with the digital system. If now it has to be controlled, again that digital system data is given to the D to A, and a digital to analog converter, and from the digital to analog converter, it generates the electrical signal. So these electrical signal pass through the relay. So relay will connect it to the on and off condition. So that's exactly the controller does its job. And third one is processor. Whenever data is given into a system, I need to make a decision. So whenever I want to make a decision, the processor will play the important function. So what this processor does, it got already the stored information, and with the dynamic information, it is fetching the data, and then it is comparing and making the analysis. And based upon the analysis, it will try to communicate with the external devices. So what will happen? It collects the data from sensors through the controller in the form of digital signals, and then it will process them. And after processing them, the processor is to collect all the data, arrange them, process them, and the processor also removes unwanted data. If it is if the temperature is within that limit, it becomes the unwanted data. No need to store that, leave it. So that what will happen? The data in the system will be less, because we cannot keep on using the large data into the memory. It's a waste of energy. How best I am able to minimize that? How best I am able to use? If you have the minimum data, accessing becomes faster, and you are able to process the data faster. Hence, the cost of the system will be reduces. Then we have the gateways. So gateways are responsible for transmitting the data, either incoming or outgoing, to the IoT system through the internet. And these gateways will help how to store it in the different servers, and how to use the protocols, and how to use the modems in the Wi-Fi system, and through that how we are able to communicate. So now we are using the mobile systems. So the provider is the gateway. If I'm using Airtel, BSNL, whatever it is the gateway. So through that gateway, you are trying to use the data, and you are able to access the data onto the mobile, and then you are trying to use it. Similarly, the gateways, which are going to be used in the system. Then we have the cloud server. So cloud server is basically holding the data, and whenever you ask the data, it will try to give it to you. Say SCADA is one of the important digital control system, which is very often used in most of the electrical appliances condition. So here the cloud server will take care of the data which is generated with respect to the input, and make use of the internet and communicate it to the system. And finally, we have the user's device. So these user devices are getting what are the different smart devices you are connecting to your internet, or you are connecting through your IoT. And this is all the devices you need to activate first. Simply by connecting, it won't work. You have to activate, initiate, then you have to make use in the system. So these are the basic 6 components which we are trying to use in the IoT module. So if you look at, okay, I have connected IoT, I got all the components. What is the advantage of this IoT? So the first one is improved customer engagement. So in the customer engagement means customer can be always a passive component. See, once I connect the system, I don't want to interfere in that. It has to be done automatically. So that is what called the customer engagement. So it will try to identify the flaws or the accuracies or whatever the engagements in the system. So nowadays, one example I want to quote here. My car is standing outside and now I want to get into my car. If I get into my car, what will happen? If I get into my car, what will happen? It is too hard to sit inside the car. So before me reaching to the car, if I make the air conditioner on, by the time I reach the car, what will happen? The car becomes cool. And once if I board into the car, I will be comfortable. So this is what I'm expecting to be done by the system. And second thing is, now you look at the Tesla cars. What will happen? If I want to get into the car, what I have to do? I have to go to the parking place, find my car, and unlock it, and then get into the car. This is a common procedure. But what the Tesla advantage is, you wait near the main gate or wherever the lobby or wherever you are, you just provide the data saying that come to lobby or come to main gate. The automatically it initiates, it will switch on, it makes the AC air conditioner on, and then it will move automatically without driver and it comes to the main gate. Once if it reaches the main gate, you get into the car. So what will happen here? Customer engagement. According to the requirement of the customer, how you are trying to provide the services. How you are trying to provide the services. So here we would like to have the improved customer engagement. And second one is technology optimization. Technology optimization will tell us that how much hardware or how much software you are trying to use in the system. So there should be minimum hardware and minimum software has to be used so the system becomes faster, so potentially stronger. So critical conditions have to be taken care in the technical optimization. And third one is reduced waste. So whenever I'm talking about the waste is the resources. So there should not be, the resources should not be get wasted. Means if I'm using it anything, it is the useful. If I'm not using it, it becomes the wastage because nobody is using, it becomes the waste. So it is the loss of money, loss of energy, everything. So one example what I can say is with respect to the food. If I want to eat some food, I have to take only that amount of food. And I should not get more food, eat half of that and throw away the other thing. So that is called the waste. It can be used by somebody else, but I am taking it, but I am not using it. That is the waste. So here we have to be very, very particular about these things. So as I'm talking about the food and waste things, Germany is the best country where they are very, very particular about the food. Even if you go to the hotel, you order something, you have to eat completely. You cannot waste anything. So they will straight away fire you. So because they know that the importance or the uh, whatever the food you are using, how much time it will take to grow and other things. Say one example, if you are using the rice, it is taking almost about 600 liters of water to grow few grains. So when you are using so much of energy and everything, and you are not eating it comfortably or you are throwing it, then it is a waste. Likewise, even in the energy also. If you are using the energy, there is absolutely no problem. If you are not using, then you have to ensure that you should not waste the energy produced. And then next one is the enhanced data collection. That means it will got the lot of data. Based upon the data, you are making the decisions, whether it is required or not, whether I have to analyze and during this time, whether I need this particular equipment to be on or off. So all this is based upon the data. So IoT is capable of doing that enhanced data collection. And how to connect the IoT to the energy sector. So we got two things. One is lighting systems and smart grids. So lighting system is what we are using in the residential purpose, buildings, in commercial applications or whatever it is. And second one is the smart grids, from where you are getting the energy. So in the smart grids, we have the electric meters, home automation system, and industrial automation. So electric meters, already I said you, it gives you the feedback. So based upon the feedback, whether you are using the limited energy or you are using more energy can be specified. Home automation is whenever the certain things are not in use, you automate it, automatically it will get off. So whenever you say, example, refrigerator, when you open the door, the inside light will become on. And when you close the door, automatically the light will goes off. So this is kind of automation which is required in the system. So here in the energy sector, how we can control the consumption of energy and how we can make it more efficient. So what are the different sustainable energy managements are going to be used? So first one is optimize energy usage. That means the IoT will make a decision based upon the data, based upon your previous history, or when and how much energy, what kind of energy you are using. Based on that, it will optimize the energy usage. It tells that during this time, you can use more energy, or during this time, you can use the lesser energy. Somebody is taking care of that. Otherwise, what will happen? I will switch on everything and go off. I'm not using it. So during that time, the IoT will take care of that. If nobody is there at home, automatically it switches off everything. And in the night, it looks at the lux, that is intensity of the light outside. And if it is within the limit, or if the lux is less, automatically the lights will become on. So that's how the optimized energy usage is going to be used. And second one is improving grid reliability. That means whenever I'm getting the energy from the grid, if I'm very much consistent of getting the energy, then the grid will provide you the better and efficient process. So that's where we call it as the grid reliability. And third one is promote renewable energy integration. So that means if I'm using grid, that is one energy. If I'm having a solar system, that is the second energy. If I'm having the wind energy, that is the third energy. So if the sun, if I'm using the solar energy, then my home applications, everything will use the solar energy. During that time, I'm not using anything from the grid. And if the wind is very high and the wind generated energy is better, then I will use the only wind energy. I will discard the solar and the grid. There is no sun energy, solar energy, there is no wind energy. During that time, I can make use of the grid energy at any point of time. I should not get power failure in my system. So that is called the integration, connecting several things to the system and getting connected to only one system at a time, which gives you the better output. And the fourth one is real-time monitoring. Real-time monitoring is who and when, how he is using. So based on that, the control of these devices is going to happen. Load forecasting. So load forecasting is during summers, we use the air conditioners very much, but during winters, we will not use air conditioners. So that is what the load forecasting. That means now this particular house will require this much amount of load, and that is getting added to the grid. And now the grid person will come to know that for this entire area, what is that load required at different times. So accordingly, he will try to schedule those loading. And the predictive maintenance. Predictive maintenance is you have to ensure that when is your system needs attention on the maintenance. Then now you are using the batteries for the inverters. So every 6 months you need to put the distilled water. So that is called the maintenance. So predictive, that means before 6 months it has to predict and it has to intimate you, saying that now it is getting exhausted. You need to provide or pour the battery, distilled water into the battery. So how these energy management has to happen? So here we go for the smart commercial buildings where the entire building is automated and it is going to be controlled through the IoT, and the lighting and everything is going to be making use of the thermostats for the switching on and switching off of the system. So that will reduce the energy waste in the system. There was one fantastic example. When you are moving on the street, what will happen? There are going to be street lights, which are there. Say 100 street lights are there, and you are the only one person who is walking on the road. So at a particular place where you are, light is required. In the other places, light is not required. So what will happen? Automatically, the place where you are, the light will be on. One ahead and one behind. So 3 lights will be on at a time as you are walking, and remaining 97 lights are off. So that will save the energy. If nobody is walking on the street, no need of light. So automatically it will goes off. So that is called as the smart commercial application. Okay. Then industrial energy optimization. So in the industrial thing, so you need, based upon the industry requirements, you have to provide the energy. So that is again IoT controlled. So in the factories, most of the time it works on the daytime. So in the daytime, the residential people not required very much power. So divert entire energy to the factories and get the work done there. And during the night, factory is closed, but the household people are using maximum energy. So provide them the system. Then we have the ventilation on demand. Ventilation is that if a proper ventilation is there, no need of the more energy, airflow. Say, for example, if you are going with the vehicle or something like that, you are burning the petrol along with the air. So when you are burning, petrol is more, it converts into the smoke. It will not convert into the energy. So that is wastage of the resources. So here, something like unnecessary resourcing is there. So it will sense and it will work on that. Then you have to use the renewable energy monitoring. Whoever gives you the better voltage or current, whatever it is, you try to make use of them. Then the digital twins for energy efficiency. So when you are going for the application, first you simulate the situation. So based on the simulation, you can make an anticipation that this is the amount of energy is required. Then you provide it to the actual. So that is called as the digital twins in the system. And what is that IoT system management really looks for? So it looks for the crucial and efficiently handling numerous connected devices, and they have to work in the smooth operation, and they have to be secured, and function should not be get affected. Some devices require more current, some devices require less current. Accordingly, the system has to provide that. So that is called the management. And second part in that is remote configuration. So in the remote configuration, it makes the system more secure and reliable. So you are configuring the system when the system has to be on, when the system has to be off. So that is through the software you are trying to manage the things. So whenever I'm going for the IoT energy management system, so I'm looking for the real-time energy monitoring. At present, the IoT will sense the data and it will tell what exactly is happening with respect to the devices. Real time is as of now what is happening. And based upon that, the AI-driven predictive analytics will tell that at this particular point of time, whether the demand is more or less, and how to make the optimized things, and how to make the inefficiencies has to be get reduced. Smart grid integration, it will balance the supply between the more demand and less demand areas, as I told with respect to industry and home applications. And the next one is the automated energy optimization. So there are going to be certain strategies. So through the strategies, you try to use the energy optimized. Demand response management, where the energy consumption has to be controlled through the grid based upon the trends and the requirements of the system. And energy storage and load shifting. When you are working on the battery energy has to be used. And when you shift onto the grid, the battery has to be get disconnected, or any other renewable energy has to be get disconnected. And carbon emission reduction. So it will help to minimize the carbon footprints by optimizing energy distribution. So when the carbon emission is there, whenever the proper utilization is not happening, during that time, carbon is going to be created, as I told with respect to the vehicles. Petrol is there, burning is there, but you are not using it for the moving the vehicle. So that is where the carbon is going to be more. So you need to ensure that how to minimize this carbon footprints, and you need to predict. Whenever you are using the system, you need to predict, and accordingly, you need to work with the system. So this is one simple schematic of the IoT for different applications, how you can make use of the IoT system. So now you look at IoT is got, and what are the different functions it has to do, we got it. Then what is this system management? System management refers to the process managing the entire life cycle of Internet of Things, devices and sensors, from planning and boarding to the monitoring and maintenance through the retirement. That means the management is from the input to the output. The entire process has to be controlled, and it has to work according to the requirement and according to the process. Then only we are able to do the things. So somebody has to do that management. So IoT will take care of that management. So here, whenever the system want to be more better, so we need to have the smart sensors and data collection. Smart sensors is get the desired data. If the unwanted data is existing, you try to discard that. Collect the data. And these data has to be stored. Move it to the some memory location, that is connected devices and automation. Then energy has to be, or whatever the data is, has to be stored in the cloud. And you have the edge processing. Edge processing, already we have discussed that. Whenever you want to make the decision, based upon the edge processing, you have to make the decision and try to develop some algorithms. Through the algorithms, improve the efficiency of the system by detecting the inefficiency and the faulty process in the system, such that we are able to improve the sustainability of the system. And based upon the demand, the smart grid has to work, whether to allow or not allow in any given real time. The what are the different renewable energies are there, how we are able to use them and interconnect them. Then what are the trends of this renewable energy is there? So why we have to use these IoTs? So first one is lower carbon footprints. That means try to reduce minimum the wastage of power. So optimize the system, and it improves the efficiency of the system and reducing the emission. So when you are not using them, it causes the emission of carbon. So you try to avoid that by switching it off. So you are able to reduce the carbon footprints. Second one is enhanced renewable energy integration. Try to use solar, wind, or whatever the other fossil fuels are there. You are trying to make use of them. And reduced energy waste. So automated demand response and predictive analytics prevent the overproduction and unnecessary consumption. So energy management is clearly talks about unnecessary consumption. If it is not required, switch it off automatically. If it is required, you use it. Decentralized energy systems. So where the IoT will take care of the peer-to-peer energy trading fastest, and it will try to provide the decentralization. That means if in a colony 100 houses are there, all 100 houses are going to be seen in a different manner. So that is called the decentralization. And smarter infrastructure. So it is make a cutthroat decision to say or use in any system or not to use any system. So in the smart grid management, we have three things. One is real-time monitoring. At present, what is the use? Really, he needs that amount of energy or not. By means of sensors, you read it. By means of algorithm, you analyze it. And then you allow that power to use or not allow to power use. And load forecasting is, so you make a decision that now this particular, see example, in the morning, we are using the water heaters. So it has to predict between 8 to 9, the water heaters are going to be on. So more power is required for this particular house. So you try to provide more power. And after that, we are not using. So we all are going to office. Nobody is there at home. So zero power is required. So then you turn off everything such that that power can be used in somewhere else. So this decision has to be made based upon the previous or the historical data and other parameters, what we are trying to work with the things. And third one is optimized. Then you try to use only the specified and optimized load, and you can reduce the waste in the system. And why this renewable energy is required in the system? So that is the predictive maintenance. So explains how artificial intelligence can analyze the data from renewable energy system, and you are predicting the failures, and you are trying to improve the maintenance. So here we call it as the redundancy. Redundancy is there any other alternative, quick alternative, such that to maintenance the system? So normally with respect to the telephone exchange and other things, we have the redundancy called the cold processor. If one processor is used, it is called the hot processor. Because of some problem, if it is failed, then the entire network will fail. So it has to be get transferred onto the code such that the disconnecting time is going to be very, very less, and you are able to use it for other things. Then optimal power generation. So whenever you have other alternatives, you try to produce the optimal power and try to use these systems. And what is the programs? Demand response programs. So automated. So you make the whole system as automated. And behavior analysis, when the power is required more and when the power is required less. When is the peak time and when is there is no peak time in the system, that you have to make the decision. And whenever I'm talking about the management, that is process management. So data collection and transmission. So how you are getting the data and how you are transmitting. Integration with AO. The power, whatever you are taking, integrate it with the algorithm. So algorithm will make the prediction and maintenance is going to be done. And then finally, you have the case studies. Few case studies of the grids, the renewable energy, and energy efficiency can be discussed, and we can work on these things. And we can apply the artificial intelligence and other cases onto this. The challenges are data privacy and security. Whatever the data is there, it should not be given to somebody. So the security has to be a proper. So my data should not be get theft by the other people. Scalability and complexity. So scalable means what is that energy is required. So that I have to tell. And ethical considerations. Ethical consideration is the thefting of energy should not happen. So the algorithm has to take care that ethically it is right. It is doing the ethical jobs. Then only you can make use of it. Otherwise, it should not be get supported. And sustainable energy, already we have seen this. And to conclude, the IoT-enabled energy management is revolutionizing how societies pursue the sustainability, improve operational efficiency, and reduce cost through the real-time data and predictive analytics. The continuous advanced in the connectivity AI edge and cloud computing are accelerating IoT's transformative impact on the energy system globally, and it is able to facilitate the energy devices and grid for sustainable development and addressing to the changes occur with respect to the data privacy and crucial applications. And as we are ongoing digital transformation in the energy sector, as I told, the cables are replaced with Wi-Fi. So again, IoT will have the importance, and collaboration with other technologies make the IoT sustainable energy management more effective in the practice. So that's what I want to tell and I want to discuss with you people. I hope if any questions are there, I am ready to take them. Thank you.
Thank you so much, sir. Anyone have any question regarding this from participants? Anyone have any questions? You can ask. Anyone have any questions?
It's okay. Thank you then. Thank you very much.
Thank you so much, sir, for such a motivating
Thank
and
you,
insightful speech. Sir, your speech and ideas have truly inspired us and reminded us of the power of determination and innovation. Your words have given us new sights and motivation to think differently and act with purpose. The experience and ideas you shared will surely leave a lasting impression on all of us. On behalf of everyone present here, I express our heartfelt gratitude for taking the time to be with us today and for enlightening us with your valuable thoughts. We are deeply grateful for your presence and for sharing your valuable time and wisdom with us today. Thank you so much, sir, once again. And sir, I want to
Thank
tell
you.
you that our beloved principal madam want to talk with you. Now I am
Yeah,
hand over this
please.
session to Principal Madam.
Thank you, sir.
Yeah.
Dr.
Hello,
Shabanira.
hello, madam. How are you?
Uh,
Thank you, madam.
I'm fine, sir. It is really an opportunity to meet with you and to get chances to hear some valuable speech from you. Sir, with the hope
Yes, madam.
in future, if we can arrange such type of program, and we would like to find you always. Thank you so much.
Yeah, sure, madam. I will be with you. Thank you, madam. Thank you.
Okay. Thank you so much, sir. Thank you so much.
Thank you. Okay.
Now I am informing few instruction for Atal FDP participants. All participants need to follow the guideline to be eligible for successful completion of the Atal FDP. That is, participants must maintain at least 80% attendance throughout the FDP. Attendance will be recorded for every session. Failure to meet the minimum requirement will result in ineligibility for certification. And a final assessment test will be conducted on the last day of FDP. Participant must score a minimum of the 70% marks in this test. The test will evaluate understanding of the key topics covered during the session. So certificates will be issued only to the participant who fulfill the both criteria. Now I am hand over this session to Ms. Komal Kumari ma'am for continue the next session.
উনি আমাদের কলেজটাকে ভালোবাসতেন।
Thank you, Aini ma'am. Good evening to everyone present here. Myself, Komal Kumari, Assistant Professor of Ramgarh Engineering College, gives me an immense pleasure to welcome you all to this faculty development program on the topic Emerging Renewable Energy Technologies, Solar, Wind and Beyond by Dr. Manoj Kumar. This FDP has been designed to address these pressing issues by exploring cutting edge innovations in clean energy technologies, climate smart solutions, and sustainable development strategies. Over the course of the program, participants will gain insights into emerging renewable energy system, climate modeling, green hydrogen, energy efficient technologies, carbon management, policy frameworks, and the role of digital innovations such as AI and IoT in accelerating sustainability transitions. It is my privilege to introduce Dr. Manoj Kumar, a distinguished academician and researcher in the field of mechanical engineering, who is currently serving as an assistant professor in the Department of Mechanical and Aerospace Engineering at NIMS University, Jaipur. He has a strong academic foundation and an impressive education background. He completed his PhD in mechanical engineering from IIT Mandi, where his research focused on advanced thermal sciences, including convective heat transfer, microchannel cooling, and nanofluid based thermal management systems. Prior to his doctoral work, he earned his MTech in heat power engineering from VNIT Nagpur in 2011 and began his academic journey with a BE in mechanical engineering from VTU Belgium in 2008. Dr. Kumar has made significant contributions in areas such as advanced heat transfer, microelectronics cooling, microchannel heat sinks, nanofluid applications, and computational fluid dynamics. His work has been published in several reputed SCI indexed journals and presented at international conferences, earning recognition, including a Best Presentation Award at ACMMT 2024. He has also worked on notable research projects, including CFD-based investigations on nanoparticle-laden cooling systems for SERB-funded initiatives at IIT Delhi. In addition to his academic contributions, he also is the inventor of a design-patented propeller fan for small aircraft. Beyond his technical expertise, he is appreciated for his dedication to mentoring students and guiding multiple BTech, MTech, and PhD scholars in thermal engineering and aerodynamic optimization. His research has resulted in numerous high quality publications in reputed journals and international conferences focusing on cutting edge topics such as CNT based nanofluids, microchannel heat sinks, and advanced thermal management systems. Now, I wholeheartedly invite Dr. Manoj Kumar Sir to take over the session and enlighten us with his expertise on today's topic. Thank you, sir.
Thank you, ma'am. I am Dr. Manoj Kumar. You already introduced me in a so nice way. So I would like to thank to the management committee who invited me to talk on FDP on climate and energy innovation for sustainable society. So should I share am I audible?
Yes, sir, you're audible, sir.
So may I share my PPT or you will share from that side?
Sir, you only share your PPT, sir.
Ma'am, is it visible?
No, sir, not yet. Yes, sir, now it is visible.
Okay, once again, thank you for inviting me.
Yes, sir.
Today, the topic given to me is wind and beyond. My presentation, first of all, I will discuss about the introduction, what is renewable energy. Then we'll secondly go from traditional, fossil fuel to renewable, and it includes solar power, wind, ocean, and finally we'll end up by biomass energy. So very basically, what is energy? So the very basic definition is strength and vitality required for sustained physical or mental activity. So now why we need energy? So now these days, if you are going for any any domain, whether it is transportation, cooking, building, or industry, anywhere, we require energy. So that's why we are mainly focused on energy. So now this is the evolution of human being. So from starting to the today era, even we are working in 6G generation, so we again moving from starting to end, we are in the same position. So in all aspect, we are looking for to get more and more improvement and efficiency. To do that, we are looking for technology, and that requires more energy. So finally, we have to optimize about energy resources. So this is the journey of invention of energy. So finally, today we are getting energy by electricity. So the significant invention by a scientist from 1745 to 1897, you can see different scientists William Watson. They discovered comprehension of current and circuit. Then Faraday invented electric motors. Then Ohm. Then Maxwell, Edison, and the breakthrough journey was Edison that founded electric light in 1876. So this is the contribution of number of scientists that have worked out for different options in electricity option. So this is very important important topic, that is Human Development Index. So what is it? HDI. So HDI stands for statistical tool that measures country overall achievement in its social and economic dimension. We are not developed only, we are focusing on technical development and not about social. So it has three different key points like long Hello, sir. Am I audible?
চেহারাটা কিন্তু
Yes,
Hello.
sir, you're
हाँ, sir.
audible, sir. Yes, sir, you're audible, sir.
Okay, sir. अभी connect हो गया. Okay, okay. Okay, ma'am. So this is the SDI index of our country from 1990 to 2017. You can see the continuous growth. Like, it shows that we are developing all aspect, whether in technical aspect or social aspect or whatever. So the next thing is we are parallelly we are talking about human development index versus energy capita. Now we are connecting our main topic to the SDI index. So as GDP increases, a country needs to use to maintain the growth. Energy consumption goes up as the GDP goes up. So in the graph, in the first graph, SDI index versus energy consumption, and the second graph, SDI index versus CO2 emission. So wherever we are talking about development, you have to use more and more electricity. So parallelly, it causes more emission. So you can see the color contour. Like the country who have high HDI, who have more HDI, are having more emission of energy. So parallelly, we have to go for this type of problems. So and now we are looking for global energy consumption from China to Iran. The China have the highest energy consumption. This is very important to study. Without knowing this thing, we can why we are looking for renewable energy. In the world global map, you can see the variations from China to Iran. We have maximum to minimum a million ton of oil consumptions. Now, in the first line, energy consumptions versus globally versus year of time, it is increasing with respect to time. The second, we are dealing with India, that is 252, 1,000 in just 30 years, that is 4 times. Now, in the terms of percentage, it is 3.5 to 7. So the most important thing is in the last uh, pie chart, I have shown the different fuels that are being used world over, that is oil, electricity, gas, biomass, and coal. So oil and coal, that is hydrocarbon. So that is the main issue. If you are burning this by combustion process, oxidation process, it will emit CO2 and CO. That is the main issue why we are diverting from a traditional fuel to renewable energy. So as a consequences, in the previous slide, we have coal and oil. So as you will earn one coal and oil, that will produce CO2. And you can see the graph from 1975 to 2020, that is drastic change from 330 to 410. Almost near about 33% emission is increasing. And that indirectly increases temperature. So in the next slide, you can see the rising global temperature. So 1880 to 2020. So you can see a drastic change, 0 to 1, almost
Hello,
100%
sir.
rise in global.
Manoj, sir.
By if you are talking
Hello,
about
sir.
percentage, it is
Manoj,
almost
sir.
100%. So these all things
Good evening, sir.
finally moves us to move toward
Your
from traditional
slides
fuels
are
to
not visible.
renewable energy. So
Dr. Manoj, your slides are not visible. Only one slide, what is energy, is there. We have skipped around 4 to 5 slides. We are not able to see.
Yeah, Manoj sir.
Sir, am I audible?
Audible, sir, audible.
Okay. So slide.
This is your slide, na, sir?
Yeah,
Implication of
yes, sir. Slide. Either you will scroll the slide or I my.
we are sharing the
Sir, we
slide,
are
sir.
sharing
You
the
just
PPT.
tell me
Okay.
next.
Sir, we are sharing the PPT. You just you just
Okay.
tell us that we have to go to next slide.
ও তোমাকে পাঠিয়েছে তো এটা? ও তো
We are sharing now, sir.
Yes, sure, sir. Okay, sir. Go ahead. Okay.
Your
May I
slides are
start, sir?
shared, sir.
Okay, sir. So this is the concern of extra emission of CO2 that causes glacier melting, flood and all these things. That is very risky for our society. Next. Sir, next slide, sir. Okay, so another issue is that hurricane around the world, especially in Europe and other American sites. So these are the very very serious of concern. Next slide, sir. So that is big challenge. You can see whatever I mentioned earlier. You can see the things what I mentioned that is really happening in our country as well as all over the world, either European country or African country or wherever you can go. That you can see, especially European country where they are using more and more air conditions. Due to that, there is the very serious concern of ozone depletion, and that causes additional increment of temperature, and glacier melting takes place, and finally that concerns flood, and you can see the weather changes. Next. So now I have explained a lot of things why we are moving from traditional fuels like coal and petrol production, all these things. The reason is when we are going for oxidization, that produces CO2, CO, NOx, and N2, that causes ozone depletion, and indirectly they are increasing the temperature. So moving ahead, we are looking for the other sources like primary energy sources, that is renewable energy. The example of renewable energy is biomass, tidal, solar PV, solar thermal, and all these things. It includes all and especially for wind energy, hydropowers, and we are not and geothermal power. So we'll discuss one by one about why we are looking for these things. What are the additional advantage over the traditional fuels like oil and other things. Even we are looking for nuclear reactor, but it is very hazardous. We cannot go for that. Next. So we are talking about solar energy utilization. So sun is a source of energy, and we have just
I think, sir, you have some issues in your network. There is no sound from your side. Am I audible, Manoj sir? To all the participants, I guess there is a certain problem in the network of Manoj sir. So please give us some time so that uh, our speaker can give his presentation. We are very much sorry for this inconvenience, but I think the network in the guest speaker's domain is out of reach. So please be patient. We are trying to contact our guest speaker. Your audio is muted, sir. Manoj sir, your
Okay, sir.
audio.
Now,
Yes, sir, you are audible
yes,
now.
sir.
I am sharing the
Okay.
slide.
Okay, sir. Okay, sir. So in the previous slide, I have already seen that there are two ways to use solar energy. That is, one is active way and the second is passive way. So it depends on the application. So in this slide, so I have shown there are two part of solar active solar energy utilization. One is next. Next, sir, next. So this is a very important slides. So this is the type of solar energy collectors. Back. Back slide, sir. Yes, this one. So on the application of solar energy, it is classified in two types. One is solar thermal, and so the second one is solar voltaic. So the output of the solar thermal, that is heat, and the output of the solar voltaic, that is electricity. Now we are mainly concerned about the solar thermal, and the instrument that being used to use the solar energy, that is collector. That is name itself reflect that is solar thermal collector. So it it absorbs solar energy from the atmosphere. So that this is the classification. One is non-concentric and the second is concentric collector. In non-concentric collector,
तो आप छोड़ दीजिएगा मुझे
in non-concentric collector, there are two types. First, evacuated ETC, and the second is flat. And the second is concentric type collector. That is parabolic, Fresnel lens collector, parabolic this. So the thing is depending on requirement of solar energy just to hit the things or other application. We are mainly concerned for type of collectors, right? So these are in picture I have shown different type of like parabolic, flat, and Fresnel, all these things. Next slide.
जाइए इधर आराम से खा के आइए
Next slide, ma'am.
Excuse me, can
Next.
FDP can mute themselves because Manoj sir's voice is not getting proper. Can the host mute?
Yes. Am I audible, ma'am? Am I audible?
Yes, sir, you are audible, but the FDP host is on unmute, so their voice is also coming. Now you can go ahead.
Okay. So can you
Yeah.
share the slide? Can you share the slide, ma'am?
Yeah, they will share.
Yeah. Go ahead.
Yeah, thank you.
Okay, back slide. Previous one. Am I audible, ma'am?
Yes, sir, you are audible.
Yes,
Yes, sir,
sir.
you are audible.
Okay, sir. Okay, ma'am. So from the previous slide, I have discussed about the different type of collectors, for flat plate collector and parabolic collector. So now the most two important thing, that is flat plate, what ETC we are comparing the performance. So the first thing is, due to the vacuum in the glass tube, ETC can retain high percentage of collector heat, right? So that's why it is more applicable in the general cases. Second thing is, it is applicable in other conditions like freezing condition, where flat panel will not work. The most important point in this area is evacuated tube collector in cold climate can be installed even at high angle to better phase. So it is mostly applicable, especially in the Himalaya, region where we have high altitude. The next point is, in the area where we have heavy snowfall, the design is made in such a way that, if any snow is, settled over the surface, normally just get down. So a flat plate collector, or the other hand, will collect some heat through the reflected sun of the snow. So that is very important. So now the most important thing is, for the design of collector, it depends on our application and the geographical condition, altitude and latitude. So on the basis of that, we have to select whether we are looking at flat plate collector and ETC. Next. Okay, now this is the mathematical modeling of solar collector. So this is very important. When you are going to design, or if you are going to purchase any collector, you should know the some parameter that is called efficiency. Like, in general thermodynamics, if you are going to purchase any refrigerator, you should know the COP. And we are generally talking in terms of rating, 5 star, 4 star, like this. So similarly, for flat plate collector, we are looking for efficiency. Efficiency generally nothing but it is output upon input of any system. Input is, that is AC, the collector area, into GT, that is incident radiation. And QU is the useful output power, that is the heating of fluids. So how we calculate QU, that is very important thing. That is AC slash, it is written formula, where AC is the absorbed solar radiation. And the main thing is useful energy equal to absorbed energy minus thermal losses. When you are going to design anything, so there are different type of losses that may cause due to different methods, like conduction, convection, or radiation. So what is actual output, that is, we have to remove the losses. So this is the QH, and the QH is useful energy used to heat the fluid, that is MCP delta T. So when you are going to, and these losses is the very important thing that decide the efficiency. So if you are going to purchase any collector, you should know the efficiency. That is the mathematical modeling. And when you are going to optimize in some parameters, especially for design or thermal, you should know this equation. Next. So the potential of solar heating. We have, in the last slide, we have studied the mathematical modeling. In this slide, we'll talk about what is the potential of solar heating, that is especially in temperature range. Where you are selecting solar thermal energy for some application, you should know the range, it varies from 60 degrees to 250 degrees. If we have any processing industry, if temperature ranges from 60 to 250 degrees required, then also we can go for solar collector energy. And as per energy policy report, in India, 10,800 terawatt watt hour total energy consumption, that 45% of total energy is used in this industry. So that is very significant number. And out of which 25% energy is used in heating application, where temperature require 60 to 250 degrees. So the 2-3 parameters like the temperature range and the requirement, that is very important driving parameter that forced us to study solar thermal energy for our development. Next slide. So this is the versatile study of solar thermal utilization. It covers entire domain of industry, whether we are talking about food processing or beverage or paper industry or textile or chemical or big and blocks, plastic industry or major industry sectors. You can see in all operations where temperature ranges from 30 to 90 minimum to maximum, like 200 to 220 in separation in plastic industry. In all aspect, the potential of solar thermal energy utilization is we can actually use for that. So and that is the beauty of renewable energy. In all domain, in all sector, in all operations, where temperature ranges from 30 to even 220 degree, we can directly or indirectly use solar energy. That's why it is very versatile field to study. Next. So on the basis of temperature range, we have different types of collectors. So when we are going to select any collector, you should know the operating temperature. If it is less than 80 degrees C, then we'll go for flat plate collector. If it is 80 to 225, like medium temperature, then we'll go for concentric collector. If it is more than 250 degrees C, then we'll go for some different, we will optimize or modify the collector, and we'll add some tracker so that it can track the solar radiation in all aspects from morning to till sunset. So that's why this is very important parameter, that is temperature range. Next. So this is the vast application of solar energy. That is, we can use solar thermal energy for heating. We can go for steam generation, especially in power plant. Then we go for space heating, in winter and summer. Then solar cooker, solar dryer. Even we are working on solar refrigerator also. We will not use electricity from power plant to operate our refrigerator. Then especially for water distillation, especially in Saudi Arabia, where there lack of water problems. So distillation is a very important issue. Even in India also, a lot of people are there is so much pollution in water. We need distillation. So we cannot go for each in all aspects by electrical energy to pure the things. So we have an aspect of solar thermal application also. Next. So in the previous slide, we can conclude that no sector is left or no operation is left where we can not use solar thermal energy. That's why it is so versatile and so beautiful. Now in this slide, we have mentioned about the collector efficiency versus delta T by G, where G is the irradiation. For the different application like space heating or hot water heating or pool heating, air conditioning, on the basis of delta T, on the basis of delta T by G, we have, from this slide, we can choose different type of solar collector on the basis of collector efficiency versus delta T by G. So this is very important graph when you are dealing with the design of any solar collector for a specific application. Next. So this is the pictorial presentation what I mentioned earlier about the different applications like solar water distillation. Solar water distillation takes place in a different manner, traditional manner. Then we use flat plate collector. Then we go for parabolic trough collector. In all aspects, but it depends on the quantity, how much quantity we are going to distill. So on the basis of that, or we are using different type of collectors. Next. So water output. Once you are going for solar distillation process, it is very important to know the output. it is general concern for all type of equipments, whether you are dealing with solar cooling or solar heating or whatever process in industry. So output is very important. That may be measured in terms of efficiency or some other terms. But in this case, they have mentioned about solar steel production is a function of solar energy. That is the input power and evaporation. When you will go for calculation, so it is very important to know the latent heat of evaporation, that is for water 2,226 kilojoule per kg. And a solar steel produces about 0.8 liter of purified water per sun, that for 1 kilowatt hour. So sun is abundant in nature. There is no lack of energy to solar energy, so we can go for a long time, even for long scale. This discussion deals about that thing only. Next slide. Now we have discussed about a lot of applications in different industry for different process, even at all different operating temperature and for all aspect. And we can conclude that by the use of solar thermal energy, we can replace coal and other petroleum products for our application. So the one solution we got, that is solar thermal energy for the all aspect in industry. So we can use this technology to increase HDI index that I earlier mentioned in the starting of the slide. Then we'll go for the next renewable energy, that is wind power. Wind energy is available everywhere, and basic working principle is based on the wind turbine. And this is the wind turbine. It contains a rotor blade, tower, needle house, electrical generator, all these things. So modern wind turbine installs and wind farms. There are some advantage and limitation of wind farms. And the second thing is it has some aspect of socio and economic advantage and disadvantage that I will explain the next slide. So what is wind? Wind is air in motion traveling between area of different pressure or between the pressure difference. So according to Pascal's law, or according to Bernoulli's principle, total energy convert P plus delta P plus rho gs plus half rho b square equal to constant. So total energy is constant. So there is movement of air wind due to only temperature difference. So even uneven heating, and that causes pressure difference causes in environment or atmosphere due to uneven heating of Earth's surface, right? So warm and light air rises. Warm and light air rises due to it, because it becomes lighter, and due to density difference, it moves in the vertical direction, and due to natural convection process, heat transfer takes place, and that carry enthalpy as well. So in the picture, you can see whatever I explained in my PPT, that is cool air over land, then high pressure, it is moving in the wind direction, then low pressure, then again it is heating and going the other direction. So even it is applicable for cloud also. Next slide. So these are traditional methods when we don't have industrial revolution in the earlier times. So people used to go from one place to another place, and you can see the design of traditional boat, in a river. So you can see the design, and that was, even they don't have the understanding of mathematical modeling, then also they have developed so much beautiful and efficient system. And that travels from one point to another point by the application of wind energy. And the second one is the picture of old photos. Next slide. So again, we are going for mathematical. We are dealing with technology, so we cannot just talk about the qualitative analysis of any technology, that it is beneficial for us, until we don't have any mathematical model. Why it is important? When we are going to design any wind system or any solar system, we should know the mathematical parameters like design parameter, thermal parameter, material for the selection of materials, we should know the material property of the system. Again, for wind power, that is the very simple, that is kinetic energy equal to half mv square. And finally, it is converted into terms of density and wind speed, that is half OA in VQ, right? Where rho is the density of the air and A is the swept area of the wind blade of the turbine, wind turbine, and V the velocity. So if you are going to optimize the energy of this wind power, so we have two parameters, that is density. The three parameters, and the first one is density, second is area swept, and third is the velocity. So if you are going to optimize the system, maximize the power, you can go for all these three parameters, right? So in the graph, you can see as the velocity of rotor increases. This is a very simple understanding from equations. Then power generation is also increasing, polynomially, the power Q. Energy is directly proportional to V power Q. So you can see that if we increase the velocity, you will get the power output very fastly. Next slide. So again, it is explained in terms of the design parameter of blade of turbine, that is half rho pi ds square by 4 into nu q. Again, why we are looking for this? So we have another choice. We can increase or we can optimize the kinetic energy by the change of diameter also. So design parameter is one thing. Second thing is material selection. And that these two things are very important. So you can see the another graph. So if we have different turbine blades, and if you want to compare the things and the power output, you can see from the graph for the different diameter, you have if the diameter is increasing, power is also increasing. But the second disadvantage is if we will increase the diameter, then it will be large and it will be weighted. It has high weight, so it requires more energy. So to also optimize the diameter. You cannot go for infinite diameter of the blade. Next. So this is a pictorial study of wind resources in India. From color contour, you can see the minimum value is from 200 to 250 and maximum is 350 to 450. That is pink and yellowish. You can see the actual location. From this graph, we can understand that you cannot install wind power in Uttar Pradesh, Bihar, or Himachal Pradesh or Northeast. It will not work. The thing is the velocity of wind. So what we explain the mathematical model in terms of velocity and in terms of diameter of the shaft. So it is applicable only in the coastal area of Odisha, Andhra Pradesh, Kerala, Goa, and Gujarat, Maharashtra, only this. So this is very important where we have to install this type of system. So this is the complete visualization of the spreading of where we can install or we can set industry, set company, factory, where we can use the maximum wind energy that we can commercialize for our profit from the company point of view. Next. So there are some important features that we should know for the selection criteria for windmill installation. The first is wind resources, then environmental impact, all these things. The most important thing is minimum risk of agroforest operation. It should be close to suitable electric grid. Whatever energy that is being generated, that will translate so that we can transfer this wind energy to the electric grid for the further use. Most important thing is superior wind speed. Without wind speed, you cannot go for optimized wind power. Next is privately owned freehold land. Land is very important for the installation. Significant potential for revalidation. Land is used primarily for grazing and cropping. These are the very general and basic understanding for the selection of windmill installation. And especially it should be significant in tourism infrastructure in India. So people can also go to that area to just see how windmill installation takes place, how it is working, and how it looks like that. So these are the very basic understanding. Next. So site selection criteria for offshore windmill installation. The first is distance to land and to harbor. Next one is water depth and sea wet property. The most important thing is environmental impact. So whatever you are going for the development, it should not affect HDI index, human development index. That already I explained in the first slide. So whatever development we are going for, that it should be user friendly, environmental friendly. That will help for the further development. Next. So we have studied about mathematical modeling of wind turbine. So what are the way to improve wind turbine output? The first is in the mathematical equations. I have explained that is faster wind speed, and we go for blade, and there are different parameters like the angle of blade, the thickness of blade. It is similar as turbine in hydro power. So larger generator. It also because we require generator just to convert this energy into wind energy into electrical energy, and finally that will generate electricity. So these four are the important parameters. That is velocity, that depends on geographical condition. Second is angle, that depends on design parameter. And one more thing, that is material selection. It should have a high thermomechanical property, so that it can resist bending or twisting when it has some severe conditions. Next. So if you are going to do for a study for any important thing, so the first important thing is what are the advantages? Why we should go for that? Without this objective, nobody can go for any technology. So the first thing is renewable and sustainable source. It is renewable, no gas emission. There is no cause of global warming. There is no cause of that will impact the society or the surroundings or the environment. Second is reduction of fossil fuel consumption. Means we are exploring the alternatives. So we will not depend much more on the fossil fuels when we have some alternatives. Then free resource. Wind is free. They nothing to pay tax for use the wind. Second is small carbon footprint. Then land utilization the better. These all wind power is installation, it takes place on the coastal area where we don't have any industry or like this or especially for agriculture sector that we have to pay on that cost. Next, both industrial and domestic turbine exist, a range of sizes. So it depends on our wind velocity and our requirement. So especially in that case, also we are looking for large generator to convert wind energy into electrical energy. Then can provide power in remote location. So in some area of India, especially in western Gujarat or Maharashtra remote area, where it's very difficult to supply energy from the main grid that is based on fossil fuels. So we have some alternative or to just provide the people who is in the remote area or country by the use of wind power. And it is continuously updating technology, low maintenance cost, low running cost, low local job creation. And main important thing is socio-economic factor. When you are applying any wind power system in remote areas, so the local people will get job. And that will indirectly increase the HDI index of our country. It requires less maintenance because we have very small, compact technical systems or mechanical system. So it's very low for the maintenance point of view. So indirectly, by studying all these advantages, we can say that in India today and in future, there is very versatile possibility to go for wind farm, especially in the coastal area of Maharashtra, Tamil Nadu, Kerala, Andhra, and all these things. So we can go for wind power in a larger scale, not for just for socio-economic, but for commercialized economic system. Next. Can we go for next? Okay, so this is a pictorial presentation of how wind turbine works. The first thing is it has shaft, it has rotor, it has blade. So the shaft turns a generator which converts the kinetic energy into electrical energy. A transformer is there that converts electricity to the right voltage for the local network type, like 11,000 volt or 33,000 volt. The wind passes over the blade and make them turn. Next, the blade turns a shaft within the nacelle at the top of the turbine. And finally, the electricity is exported to the local network. So this is the thing what we can see. But the physics behind that is there is drag force and lift force. I'm already teaching some courses in NIMS University where we are talking about drag coefficient and lift coefficient. When air is flowing over the surface, it creates drag and lift. Due to that, it has rotation, and due to rotation, it has energy. So, and there are some angle, optimized angle between the blades that will increase the finally the output of the power. So it is very difficult to design a blade. From naked eye, we can see that it's very simple to rotate. But when you are going for designing these blades, it's very you have to check the stability for mechanical strength as well as aerodynamic strength, because we are dealing with the blades. So these all parameters makes it more technical for the designing. Next. So whatever we have earlier discussed about the mathematical modeling of wind turbine, then we had some advantage and disadvantage. Then we had the pictorial study of wind energy all over the India. What are the scopes? How we can go for that? How we can commercialize it? So finally, in the previous slide, I've shown about the working principle of wind turbine. So what are the components? So this is the technical aspect. So it is a combination of mechanical and electrical components. You can see blade, rotors, brake, yaw drum, yaw motors, the generator, wind vane, anemometer, and controller and gearbox. So this is very small, combination of mechanical and electrical system that creates a huge amount of energy from wind power. So, and maintenance is very less. So we can go for commercialization in even in remote area and for the development of our country. And especially it is replacing our fossil fuels very fastly. So that is really an interesting topic for our study in future. Next. So I have from the previous study, I have explained why we are looking for renewable energy. So the first we explained that due to the use of fossil fuels and petroleum products, due to oxidation of these products, it emits CO2, CO, NOx, and other things that indirectly increase the temperature of surroundings, and that may cause global warming and all these things. So just to remove these problems, we shifted to renewable energy. So first we discussed about the solar energy that is extremely versatile and user friendly. And we discussed about the different advantage and disadvantage and different types of collectors. Then we moved for wind energy. And there also we have seen that, but in wind energy, the problem is we cannot use in some areas, especially in the UP, Bihar, and Himachal Pradesh, where we don't have sufficient wind velocity. So that is the restriction for wind energy system. But it is not a restriction for solar thermal energy, that is versatile. And in the 80 to 90% of area, people are generally basically using solar collector for the energy generation. Now exploring to the option of fossil fuels, we are looking for the ocean energy. It is also called ocean thermal energy, that we will discuss about different terms in these slides, next slides. That is availability in Indian context, where we are getting ocean energy. Then what are the conversion process, technical aspects. Second and third one is the tidal power basic conversion principles and challenges. Then we'll go for primarily energy supply, and finally we'll assess the system whether it is sustainable or not. Next. So this is a very beautiful picture of ocean energy. That is, we generally observe these things when we go near the sea, and that is really beautiful. Sun is rising, like and you can see the pattern of water that is called tide. Next. So what is ocean energy? So ocean energy replenished by sun and through tidal influence of the moon and sun gravitational forces. Near surface wind induce wave action and causes wind blow current at about 3% of wind speed. Now the most important thing is ocean surface energy, surface heating by some 70% of incoming sunlight add to the surface water, thermal energy, and causes expansion flow. Wind energy is stronger over the ocean due to low drag, although technically only several are from ocean energy. So 70% of the Earth's surface and are like full of water, that in forms of wave, tidal or marine. So we can go for ocean energy. Next. So this is the beautiful picture of tidal when we have solar or when sun, moon, and earth come into place due to gravitational pull. That I will explain in the next slide. That is a very beautiful pictures of our tidal, from where we'll extract energy of the from the wave. Next. So tides are formed because of interaction of gravitational force between Earth, Moon, and Sun. This is the technical reason why tide takes place in the ocean. So this is the region that is the gravitational force by Earth, Moon, and the Sun. Tides are usually generated at the deep ocean region, while waves are usually seen at the shallow area of the sea. So we are mainly focused on tidal energy. So whatever technology we'll use, that will go in the deeper oceanic region to install the technology. The effect of moon on tide are 2.6 times more than that of sun, influencing the tides of the ocean. In a single day, the ocean normally witnessed a series of 2 low tide and 2 high tide. So one thing is we can get the tidal energy even for all of the day in a year. So in a single day, we have 2 low tides and 2 high tides. So we can extract tidal energy even in a single day. So it is very interesting. Next slide. So that I explained it in the starting. So there are 2 tides. One is high spring tides that occurs when sun and moon line up with the earth. This occurs whether they are either on the same or the opposite sides. Mean either same side or opposite side means angle between these three will either 0 degree or 180 degree. Then we'll get high tide region. The second is low tide region. That is when it is when the sun and the moon line up at 90 degree to each other. Then we'll get low tide region. Even you can see the graph. That is periodic. High tide, low tide, high tide, and again low tide. Now in the graph, they will explain the mechanism why there is a formation of tides. So when Earth is rotating about its axis, so the water that is in the ocean also rotating about its axis, and that feels and centrifugal force. And parallelly, we have gravitational force between 2 bodies, that is according to the Newton's law of gravitation. So these 2 forces are acting on the water on the ocean, and that causes tides. And you can see the deformation of our pattern of water in the ocean, and that causes gravitation. So there are different. We have 2 different balancing points or center of mass of Earth Moon system in 2 different cases. So these are the technical reason why there is formation of tidal energy and how we are getting high tide and when we go low tide. Next. So one thing is sure that we'll get tidal energy in all the day, because in a single day we have 2 high tide region and we have 2 low tide region. Now how we can measure the tidal energy. Then you can see the scale. That is, one is tidal range, high tide. The second is low tidal range, and in between there is the tidal range. You know, and in the parallelly we have the contour. So what is the What is the, in the same time we don't have the, because Earth is moving, Sun is also moving, Moon is also moving. So the distance between these three planets are changing. So we have different, according to gravitational law of Newton's gravitational law, F equal to G(m)(1) by R square. If R will change, so obviously gravitational law will change, and parallelly that will centrifugal force will also change. So you can see the variation of the forces with respect to time. So these all things, and the second thing is the mean tide region. When we'll get the maximum, we'll get the minimum. According to that thing, we can develop our system to get the average tidal energy all over the day. Next. So again, in all slides, in all whether I discussed about thermal energy, solar thermal energy, then wind energy, or I'm discussing about tidal energy. In all cases, I have shown the map of our country and with color contour. Why it is important? The thing is, you can have the understanding of whether we can invest our money to explore, whether we are interested to work in solar thermal or wind energy or tidal energy, whether we have more suitable conditions. So from this color contour, you can see that the red color contour have the maximum value, that is total 12,455 megawatt of tidal energy is generated, especially in Kutch and Khambar. So these two important locations are there in India where there is a maximum tidal energy extracted from the ocean. And especially, and apart from that, if you go from Andhra, Tamil Nadu, and all these things, you have moderate value of tidal energy, but it is not zero. That is comparable, but the maximum point is at only 2 point, whether Kutch or Khamba. So this is the geographical and study of the distribution of tidal energy on the map of our country or near the country where we can invest all these things. So this is very important. That is pictorial study. We can just have understanding of this. Next. So what are the mechanisms that will generate tidal energy? So this is the technical aspect. So that is called tidal generator. One type of tidal generator system uses a structure similar to a dam, what we have already seen in hydropower plant. The barrage is installed across the inlet of an ocean or lagoon, the form of tidal basins. We have just a water reservoir type that stores all the energy, where we have tides, low tides and high tides. Sluice gate on the barrage control water level and flow rates to allow the tidal basins to fill on the incoming tides and to empty through an electricity turbine system on the outgoing tide. In all the time, we don't have the high tide and low tide. So just to maintain our energy system continuously, we are using generator. So we should have continuous flow of water that is being controlled by sluice gate. So by this process, it is sometimes it is similar to hydroelectric power plant. We are in winter, rainy season, we store water and we control the flow rate and we get hydroelectric power energy throughout the year. So similarly for that also, and in between of the sea, we are using installing tidal generator, and you can see in the different types of high tide and low tide. And in the low of the corner of the slides, I have shown the actual tidal generator that is being installed at the mid of the sea. Next. So again, in 1961 and 67, tidal power station bridge that was installed in France. That means France is the first country who worked on tidal energy, and it's not now. 1960 means almost 65 years back. So It is very useful. Like, the power plant which was built by Electricien de France, a precious tides coming from the Gulf of the Center on the Atlantic Ocean to turn its 24 turbines. So they used it for commercializing the energy system. So they used 24 turbines. So can you guess how much energy that is generated? That generated 240 megawatt and average 57 megawatts. That is the capacity factor of 24%. That is very, very significant. So this study explains that we can go for tidal energy generation where we have the oceans in near the country. In our country, we are surrounded by three sides are oceans. So we have a lot of opportunity to go for tidal energy generation sector. That I have already shown on the map of our country. And then power demand. Hello, sir. Am I audible?
Yes, sir. Audible, sir.
Okay, sir. Can you show the slide?
Next slide. Okay. Wait.
Next. Next.
Wait a minute, sir.
Okay, sir. Okay, sir. Wait. Okay, sir. That is types of since 3-4 slides I am discussing about the different type of tidal generators, its component and how it's working. So from these 3-4 slides we have concluded that France is the first country who mostly focused on tidal energy generation sector, and that output was significant. So, and this study also explains that we can go for that because in three sides of our country, we are surrounded by oceans. All favorable conditions are there. I have shown the color contour for our country where we can invest our money in the tidal generation energy sector. And that will also help our alternatives for fossil fuels. And generating capacity of 20 megawatt and 8 out of 30 gigawatt. These numbers these numbers motivated us to go for this study and go for this system. Next. So again, we are talking about tidal turbines look similar to wind. I already explained that it is similar to the wind turbines. So there only we are using air, and here we are using water. They can be placed on the sea floor where there is strong tidal flow, because the water is about 800 times denser than air. So this is the technical aspects where we can go for the optimization or maximization of tidal energy compared with the wind turbine. So even it is not so easy. Turbine blades are more expensive. Tidal turbines are more expensive to build than the wind turbine, but capturing more energy. What are the reason? The reason is the velocity of water is, if it not significant, the density is high. So due to density, it has more impact will there on the blades. It may cause bending. So from the design consideration, we should go for very different, like practical approach to understand and to explain the safety parameters. That's why designing of tidal turbine blade is more expensive. Next. So again, parallel similarly for the third one, every system has advantage and disadvantage. Advantage is very simple, clean and compact, continuous, predictable, life support. There is no pollution at all. But disadvantage is high construction cost, because we are going to implant the system at the center of the ocean. So that is very challenging. Second thing is may increase turbidity, the amount of matter is suspended in the water. The third one, impact of electromagnetic emissions on marine life. And finally, lack of research. We don't have sufficient literature survey on this topic or in this study. So we can extend the study for our exploration of research for the next generation very frequently. So it requires a lot of effort to study in this area, especially in tidal energy. Even though it is effective, but it requires more investment. That's why people are not going in this direction, especially in our country. Next slide. So site selection is very important. So the very basic feasibility study is that we should historic data on tides and tidal currents, acquisition of data system, and typical weather conditions. Then mathematical modeling is very important. I am mentioning this thing again and again. When you are going to design the new things, you should have some mathematical data. Again, foundation investigation, detailed analysis of various modes of operation, then detailed design, tender preparation and tendering. That is the economic point of view. So these important parameters are very important when we are going to explore tidal power system in our country. Next. So coming to the last option, we have more options. So in our slide, we started from solar thermal, then moved to wind energy, then gone for tidal energy, then we are going to biomass. In all cases, we have some limitations, especially in tidal energy. We have a lot of investments, and it's very technically challenged to install equipment at the center of oceans. And for wind energy, we have a limitation to the area. We cannot go to the upper Himalaya region, like UP Bihar region or Northeast region. And we have shown already this thing. So the third thing is for last one is biomass. So all renewable energy have some advantage, some disadvantage. So on the basis of application and availability, we have to explore and rule out which one is most suitable for our condition. Now we are looking for biomass. Renewable material originating from different type of forms. People have used biomass energy from living things since the earliest, first made wood fire to cooking, and even in the village or a country, we used to cook in the earlier time by cow dungs. So that is biomass. So each and everyone is easily they are aware of those things. Biomass is used to fuel electric generator and other machineries. Biomass contain stored energy from the sun. plant absorbs sun energy in a process called photosynthesis. So this is the technical aspect. Photosynthesis is the main reason that is responsible for biomass energy. Next slide. So this is the very basic understanding of photosynthesis. It is a endothermic process, like the combination of water and CO2 plus sunlight, that is solar radiation, that gives glucose and oxygen, right? So in the process of photosynthesis, plant convert radiant energy that come from sun into chemical energy, that is into the form of glucose. This is a very fundamental principle of photosynthesis, and this is a fundamental study for biomass. Next. Can we go for next slide? So this is from one point of view, you can see the dry leaf that is on the road, and that is biomass. That is a component of biomass. So from biomass, you can convert it to in terms of electricity, heat, fuel, and fertilizer. So these are, everyone is aware of all these things. Next. So availability of biomass. Biomass is available almost everywhere in the world. Good biomass energy resources have high yield of dry materials and use minimal land. So one important thing in biomass is what kind of biomass is more significant. So the important property is it should have high quantity of dry materials, right? Crops should generate more energy than their production consumes. Biological power sources are like renewable, is stored, CO2 neutral. So we can go for biomass because the raw materials we have that is available everywhere. Next. Next slide, sir. Am I audible? Can we go for next slide?
Yes, sir. Yes, sir. You are audible.
Okay. So now we'll discuss about the different type of biomass components. What are the raw materials? So we all are aware of these things. The first thing is wood. You can see we are burning wood to get energy, and after that, the remaining material residuals is being used for the fertilizer and other things. Next. These are the garbage. It is best for someone, but it is good for, and it is important for someone. If we are not able to understand the technology of biomass system, we can simply say that it is of no use. But if we have understanding of these things, we can use these things for our energy generation. Especially European country and America, they are using this technology very versatile. So, and by this process, we can remove the pollutants, and parallelly we are getting biomass. And we are getting energy from biomass. Yes, garbage. So this is not a best. This is a asset for our country if we know the technology. Next. Next one, sir. Can you go for next slide? Yes, again, the example of raw material of biomass is crops. We all are aware of these things. If it is fresh, that we can use. If it is of old or have some it's not it is defective, then we can go for biomass utilization process. We are using some technology to use to get electricity or to get power from biomass. Next slide.
Next slide is
Next
visible
one,
to
sir.
everyone, sir.
Yes, yes. So again, this is example of biomass system. Next. Next slide. Okay, so alcohol, you can see that that one. Yes, you can see the components of biomass raw material, that is sugar, starch, and cellulose, that is converted into bioethanol. And in these days, we are working for mainly 2 or 3 technology. I belong from mechanical background. I have done PhD in thermal management system of microelectronic cooling. So there, like, especially today when we are talking about technology for IC engines, we are looking for either PV, either electric vehicles, or we are going for bioethanols, or we are going for hydrogens. So it is one of the cleanest fuels and cheaper fuels that is used for our technology. Next. So what is the utilization of biomass utilization? That is combustion, anaerobic digestion, fermentation, and mechanical processing. All these things, by anaerobic digestion process, you will get biomass. By fermentation, you will get bioethanol, and by mechanical process, you will get oil. And all these three, biogas, bioethanol, and oil, that is used for like electric vehicles movement. So we are replacing fossil fuels, especially petrol, diesel, by use of biomass, by using biogas and bioethanols and oil. That is very, very significant. Next, sir. So what is the process? So we already studied that is good for us. So how we can do that? So that is called biomass combustion, like fuel plus oxygen equal to carbon dioxide plus water vapor plus heat. That is very fundamental chemical equations in chemistry. So biomass fuels are primarily composed of carbon, hydrogen, and oxygen. Their main product from burning biomass are carbon dioxide and water. Requirements for combustion: fuel, air, and so there are 2 types of combustion. One is pre-combustion, one is incomplete combustion, and one is complete combustion. If we are providing sufficient amount of oxygen, that will get CO2 only. If we have lack of oxygen or not sufficient, then we get CO2 plus CO also. So biomass plus air equal to CO, carbon dioxide, plus water vapor plus nitrogen plus heat. So this is the fundamental chemical reaction in biomass combustion process. So when you are going for modeling a biomass combustion system, we have to consider all these components and parameters, especially concentration for the generation of energy by use of this system. Next. So another mechanism is combustion mechanism, that is heating and drying. So there are one process is that is called pyrolysis, and it is operated at 350 to 550 degrees C. And the product of pyrolysis is CO, CO2, CH4, and high molecular weight compound gases mixed with oxygen and burn productivity yellow flames. And the next one is oxidation process. So all these processes are used to get energy from biofuels. And oxidation, it is most suitable at maximum temperature, that is 800 degrees C. Oxygen is required at the fire bed for oxidation of carbon and above the fire bed to convert CO in CO2. Combustion is complete when 100% of energy in the fuel is extracted. The conclusion from the last 2 slides is that we clearly understood the alternative fuels, but what are the mechanisms, what is the technology from where we can extract energy. So these are the process like pyrolysis and oxidation. These are the technology where we can extract energy, but you should also understand what are the operating temperature. We can use the technology according to our requirement and our conditions. So I have already explained the main stages of combustion process, and you can see the chemical component, how they are connecting like that. Next. So when we are dealing with this such type of process, we should be aware of calorific value for different type of fuels, solid fuels, gaseous fuels, and liquid fuels. So the amount of heat produced by combustion depends on type of fuel and combustion efficiency of the equipment used. So we should be aware of, otherwise we cannot calculate how much energy is being or if we are predicting some different models, or some we are exploring some different combination of components. So we will not able to understand mathematically or by numerical methods that what will be the maximum amount of energy that is being extracted by this process. So it's very important to understand, to know the calorific value of different type of fuels to predict the maximum energy output for any design or any predictive models. Next. So these are different methods of analysis that is called proximity analysis, that examines the chemical composition of a sample. These all are experimental methods. So there are other methods also, like computational method. It's not easy to go by experimental method. It will take a lot of time to understand new type of models and new type of component. So in the starting the things, we go by experiment, and for the new models or new type of composition of model, we'll go for numerical methods using ANSYS Fluent software or any other software. And the proximity analysis parameters are moisture, volatile, and these are the parameters that is important for us to understand. So from the analysis, for moisture, we have different composition of coal and groundnut and other parameters they have mentioned. And these all are done by experiments. Next. So the another analysis is ultimate analysis, more analysis of biogas is more important. That is ultimate analysis, that is helpful for determining flame temperature and fuel gas duct design. So when you will go for experimentation, you should also know the flame temperature, and how we'll get it. We'll get this from analysis, and this data will help us for the further extension or study for the new type of products. Next. So where we will do the experiment. This is the in some cold place, especially Himachal and Uttarakhand, you can see such type of system where people used to burn coal wood to just get heat from there. Next. And in general talk, we can see it as a combustion reactor. And this is the actual combustion reactor where we are going to do experiments. The composition is this is called gasifier furnace and boilers, wood chip and pellet furnace. So where we are going to do actual analysis, whatever we have explained, 3 different type of analysis, we'll do the same in this system. We'll simply put the system, and there are lots of some procedures to go for that. Next. Thank you. So due to some internet disruption, I was not able to connect properly. So I'm really sorry for that. Sir, any questions from?
Yes, if anyone of the participant have any question to sir, please ask him. If anyone have any question regarding this PPT, you can ask, or very much we are thankful to our teacher, Dr. Manoj Kumar sir. Please ask him if you have any query regarding this presentation.
Good evening, sir.
Sir, good evening, sir.
Yes, I'm actually from Chaibasa Engineering College. So, sir,
Okay.
my question was regarding ETC, solar collector.
Okay.
So, as far as my knowledge goes, sir, ETC is made up of two tubes, glass tubes, right, sir, with vacuum in between them.
Yes, yes.
So, sir, if ETC is to be used in our Indian conditions during peak summer, let's say climates, so won't the overheating damage it, sir?
Overheating damage. Means the thing is like that is the important point of consideration. We have to maintain the flow rate. So like retention time of fluid inside the pipe should be optimized. That obviously if your flow rate is not maintained properly, it will damage because there is a continuous addition of heat inside the copper pipe and other things. That's why we go for mathematical modeling to operate the flow rate, to optimize the flow rate. That is very important.
Okay, sir. Okay, sir. Thank you, sir.
If anyone have any more question, you can ask to Manoj sir. If anyone have any question, please ask our teacher about this presentation. I think nobody have any question regarding this session. It's a very much delightful session. We are very much engaged in this session. The magnetic words and the entire informative session. We are very much thankful to Dr. Manoj Kumar sir for giving us this opportunity to hear, to listen his lecture. Thank you very much, sir. And we are very
Thank you,
honored
sir.
we are very honored to have you as our guest speaker. And I will share the PPT of yours to the entire participant group. My name is Pallav Das.
Sure,
I am
sir,
from
sure.
Ramgarh Engineering College, and
Okay.
actually I am from this organizing team. And yes, in today's session, there are certain problems regarding the network, regarding the internet connectivity. But still, we hope we will once again meet together to get such insightful sessions. Thank you very much, sir.
Okay, thank you, sir. Thank you for giving me opportunity.
Sir, already Nilesh sir has already said, sir has explained the things in a more elaborative way, very elaborative way. Thank you, sir. Yes, we are very much honored to have this discussion, this informative. Actually, we are attracted to this magnetic session. We felt I know the entire participant group are, and sometimes when internet connectivity is low, we are missing something that we are losing some sessions. Thank you very much, sir. And everyone, those who had participated in this session, please you will go by the norms, go by the group norms to join at the specified time. And we will surely, some had asked me about the attendance. We will we had recorded the entire Zoom meeting attendance. We had recorded the entire sessions, even the FDP. For this FDP session there are media links also. We will provide you in the WhatsApp group. We will surely provide those who had done. If anyone have anything to say, you can ask me. We will give the entire data, entire media footages, YouTube link, and other things, PowerPoint presentation. I had already shared in previous sessions, and I will share it tomorrow with the schedule of tomorrow's session. And after the last day session, after the validity session, you will get a test, and that test will be conducted by us. And those who maintain 80% above attendance and 70% up test result will get the certificate from the Atal portal. Those who are registered from the Atal portal will get the Atal certificate. So I know you are all teachers here. So thank you very much. Very heartedly, I am wishing you everyone good night for that for today, and we will meet tomorrow again. And I request you all to join us for such. And these teachers are very much have qualification, plenty of degrees they have. We will be honored to have their sessions. Thank you very much for everyone for joining this session, and we will meet you tomorrow at the same time. Thank you all.
Thank you, sir.
Thank you, ma'am.
Any questions from any side? Or sir, should I?
Sir, I think there is no question from anyone. You had done it in very much elaborative way. Thank you very much, sir. And sir, you can leave now. Everyone can leave now.
Okay.
We will
Okay,
surely
thank you,
meet
sir.
tomorrow.
Thank you for. Okay, thank you. Thank you.
Thank you, sir.